Alrighty guys, so in the previous lecture we talked about how there's different types of elements and different types of molecules, and we said that there are three different types of molecules. Today we're going to be talking about the first type of molecule, which is called ionic compounds. Okay, we also learned last time that there are covalent compounds, which we'll talk about later. And then the third type were alloys, which we'll talk about later as well. But today, we're going to be talking about ionic compounds. Now, before we get started, let's define what an ionic compound is. So an ionic compound, very simply put, is a molecule or like a chemical that is made of metal plus a non-metal. Okay, so you should have the chart that tells you what metals and non-metals are from the previous assignment. But basically, metals, you can usually find them right here on the periodic table. They kind of take up most of it, like the very bottom and the middle and the left side. And the non-metals are going to be hydrogen and the things that are up here, the far right side. Okay, so the right side here is going to be where the non-metals are. Okay, so before we get started, let's do a little bit of review. So let's start with drawing the Lewis structures because we're going to be drawing those a lot today. So we're going to draw the Lewis structures for the following elements, and then after that we're going to figure out if they want to gain or lose electrons. So let's just go through all of them and figure those out. So sodium is right here on the periodic table. So it's the first box in the third row. Since it's the first box, this is what sodium's Lewis structure is going to look like. It's just going to be Na, and we're going to put one valence electron. Now, to figure out if they want to gain or lose, we just need to figure out, is it easier to fill up the shell like this, or is it easier to just get rid of the electron and go to the previous row? Okay, so for sodium, we should know this already, but sodium, it wants to lose one electron. Okay, and when it loses an electron, it becomes Na+. And this is going to be the Lewis structure for Na+. All right, chlorine is going to be box number 1, 2, 3, 4, 5, 6, 7. Chlorine is right here. Since it's the 7th box in the second row, it's going to be Cl, and there's going to be 7 valence electrons around it. And we know that chlorine wants to gain one electron. So if it gains an electron, it's going to have 8 valence electrons around it, and that's going to be Cl-. So this is going to be the Lewis structure for the MCI. Okay, magnesium is right here. It's the second box, so it should be Mg, and it should have 2 valence electrons. And we know that Mg wants to lose 2 electrons, so it's going to look like this. It's going to be Mg2+ because it lost 2 negative charges, and it's going to have 8 valence electrons. And then lastly, oxygen is box number 1, 2, 3, 4, 5, 6. So it's going to have 6 valence electrons. And so it's going to want to gain 2. And so if oxygen gains 2, it becomes O2-, and it has 8 valence electrons. Okay, so that's just a review on Lewis structures and whether or not they want to gain or lose electrons for their MCIs. Now, let's just review one last thing. What happens when you have a positive electrical charge and a negative electrical charge next to each other? Should remember the word that we use is attract. They like each other, so they're going to come closer together. If there are opposite charges, we know that they attract. So opposites attract. Alright, so that's going to be it for review. Now we're going to learn about ionic compounds and how they form. Alright, so just to go over some definition again, ions are very simple. It's just atoms with an electrical charge. Basically, do they have a positive charge? Do they have a negative charge? And ions are formed after atoms gain or lose electrons. Now, we said earlier in our warm-up that sodium, Na, is going to want to lose 1 electron, and chlorine wants to gain 1 electron. Okay, so this guy wants to get rid of the electron, and this one wants to gain an electron. So what happens is if you have sodium and if you have chlorine next to each other, what's going to happen is Na is going to basically just give an electron to chlorine. Sodium is going to give the electron to chlorine. Now, if sodium gets rid of an electron, what is it going to become? It's going to become positive. It's going to be sodium plus 1. And if chlorine gains an electron, it's going to be Cl minus. It's going to become negative. And you can see that there's a positive and a negative next to each other, and we know opposites attract. So what's going to happen is that the two atoms are going to come close together, and they are going to make NaCl. Okay, so if we wrote the chemical reaction for this, what would happen is we have Na, and it's going to react with Cl. And like we said, Na is going to give one of the electrons to chlorine, which is going to make it positive, and then the Cl is going to become negative because it gained an electron. And what's going to happen is they're going to come close together and they're going to form a molecule, NaCl. And NaCl, you guys might know this already, but it's just table salt. It's a salt that you guys eat. Okay, so this is your chemical reaction. And later in the assignment, you're going to have to write down how the electrons move, and this is going to be the answer for that. This is how the electrons will move in an ionic bond. Alrighty, so like we said earlier, an ionic compound is an element or a molecule that's formed with a metal and non-metal. And the name makes sense because it has to do with ions, right? One of the elements turns positive, one of the elements turns negative, and they come together, the ions come together, and they make an ionic compound. And so they form something called an ionic bond. It's basically a bond, a connection, a chemical bond, a chemical connection that's formed when electrons move. So this is another example. We have Mg and we have O. We said earlier in our warm-up that Mg wants to, not gain. Mg wants to lose 2 electrons. O wants to gain 2 electrons. So what's going to happen is Mg is going to give both of its electrons to oxygen because, again, it wants to lose 2 electrons. Oxygen wants to gain. And so what happens is Mg is going to lose 2 electrons and it's going to turn into Mg2 plus. O is going to gain 2 electrons and it's going to become O2 minus. Now if you notice, it's positive 2, negative 2. And so they're going to attract and they balance each other out and they form MgO. So this is the chemical that's going to be made. Alright, so if we drew the chemical formula for this, what's going to happen is we have Mg. It's going to react with O, and the way they react is both of the electrons are given to O, and it's going to turn into MgO. So this would be your chemical formula. You need 1 Mg and 1 O to form MgO. Okay, and this right here is called an ionic compound because it is a compound. It is a molecule made out of ions because Mg is going to become 2 plus and O is going to become 2 minus. Alright, so that's pretty easy because they balance each other out. Mg wants to give 2, O wants to gain 2. Okay, but what happens when you have something like this? So if you take a look at these two elements, we see Mg, and we said earlier Mg wants to lose 2 electrons. And then we have chlorine. Chlorine wants to gain 1 electron. We said that earlier, and we can also know that because it wants 8. So what's going to happen is Mg is going to give 1 of its electrons to Cl. And so Cl gains an electron and it becomes negative. Okay, it becomes negative 1. Now the thing is Mg still has 1 electron left. It's not happy yet. It wants to lose 2, but it has 1 left. Now chlorine's happy already. It's not going to take any more electrons because it already gained 1. And so in order to make sure this is balanced out, what we're going to have to do is we're going to have we're going to have to add another chlorine. Because if there is another chlorine, what can happen is Mg can give the second electron to the second chlorine. That's going to make this chlorine happy because this chlorine also wants to gain 1 electron, and now this one's good. This chlorine's good as well. And Mg, since it got rid of 2 electrons, it's happy. It's going to become 2 plus. And so the positives and the negatives are going to attract. So the negatives and the positives are going to come together. And what's going to happen is it's going to make a molecule. But this molecule is not going to be just MgCl because it has 1 Mg. So we have Mg. But there are 2 Cl's. So it'll become MgCl2. Okay, so just make sure you guys caught that. The reaction is going to be MgCl2 because there are 2 chlorines that are necessary in order to balance out the Mg. Okay, so if we wrote a chemical reaction, our starting chemicals are Mg and Cl, so we're going to add Mg and Cl. How many Mgs do we need? We just need 1, so we don't have to write a number. But how many Cl's do we need? We need 2 Cl's, so we're going to write a 2 in the front. You're not going to write Cl2 you're not going to write a 2 on the bottom because this is what the difference is. If you write 2 Cl's, that means we have 2 different chlorine atoms, right? So we have 2 different chlorines. But if we wrote Cl2, that means we have a molecule where the Cl's are connected together. And as you can see, the Cl's here are not connected together. They started off separately. Since they started off separately, this is the wrong way to write it. We need to write 2 Cl's to show that there are 2 different Cl atoms. Okay, and they combine together to form MgCl2. Okay, so this would be your chemical formula. And this is going to tell you how the electrons move between these atoms. Alright, let's do a few more examples. Okay, let's move this one down a little bit. Okay, so in your assignment today, you're going to have to draw some pictures of how electrons move. And what you're going to have to do is you're going to have to write the chemical reaction that takes place. So we'll talk about how to do that in just a second. Okay, so here we have lithium and we have fluorine. So we have Li. Actually, let's change up the problem. Let's not do lithium and fluorine. Let's do lithium and oxygen. Make it a little bit more challenging for us. Okay, so we have lithium and we have oxygen. Okay, so we have Li and we have O. So let's start off this problem by drawing the picture of how the electrons move. So lithium, if we draw the Lewis structure, lithium is the first element, the first box in the second row. So Li has 1 valence electron. Oxygen is box number 1, 2, 3, 4, 5, 6. So it's going to have 6 valence electrons. Okay, so lithium, we know that the MCI is positive 1. Since it's positive 1, it wants to lose 1 electron. Okay, and oxygen, we know the MCI is negative 2. That means it wants to gain 2 electrons. Okay, so what's going to happen is Li, since it wants to lose an electron, is going to give an electron to oxygen. And now this Li is happy because it got rid of 1 electron. But O is not happy right now because it wants to gain 2 electrons. So what we're going to have to do is we're going to have to add another lithium, another Li, so that it can provide the second electron that oxygen wants. And so this is the picture that shows you how the electrons want to move. We're going to need 2 different Li's to give an electron to O. Okay, that way the O can be happy because it gains 2 electrons. And so if we write the chemical reaction for this, we would just write how many of each we have and what we make. So if we have 2 different Li's, so since they're separate, we're going to write 2 Li. Again, we're not going to write Li2 because Li2 means that the lithiums were connected together. But if you look at this where we drew the picture, they're not connected together. They're separate. So since they're separate, we're going to write 2 Li. And then we combine that with an O, but there's only one of them, so we don't need to write a number. And that's going to make So all three of these need to combine. So if we're going to draw a molecule, write a molecule where all three are combined, we would have to write Li2O. Okay, the reason why we write Li2 here is because, again, here we had two separate Li's, right? We had two separate Li's. The Li's were separate from each other. We have an O that's separate from all the atoms, right? All the atoms here are disconnected, but when they combine together, right, opposites attract, positives and negatives come together, we're going to have a molecule where the Li is connected to the O's. And now, since all three are connected together, we have to write them in one chemical formula. So this would be your chemical reaction right here, and this would be what your picture looks like. This is what you should be doing for today's assignment. Alright, we're going to do one last example. If you feel pretty confident doing this on your own, feel free to do so, but if not, totally okay. I'm going to go over, well, actually, we have a couple more examples. Actually, let's skip these and let's do the hardest one. We'll do one more example. This will be about as hard as it gets in today's assignment. So, we're going to start with boron and oxygen. So again, if you feel confident trying this on your own, go ahead and do so. If not, totally okay. Feel free to work along with me. So we have boron. Boron is B and oxygen is O. So we said earlier already that oxygen wants to gain 2 electrons, and we know that because oxygen, its MCI is going to be -2. Boron, on the other hand, wants to lose 3 electrons, and we know that because boron's MCI is +3, right? If you guys don't remember this, it's the MCIs are +1, +2, +3. Here there's no MCI, -3, -2, -1, and no MCI. Okay, so I'm going a little fast right now just because I'm assuming that you guys remember MCIs and how elements want to gain or lose electrons. But if you don't remember, feel free to pause the video and make sure you go back and review that because it will be helpful. Most of the things in this class will build on each other. So if you are still a little bit shaky, no worries. Go back to the previous assignments and watch the video lectures again. Okay, so boron wants to lose 3 electrons, oxygen wants to gain 2 electrons. So since boron wants to lose 3 electrons and oxygen wants to gain electrons, we know that the electrons are going to go from boron to oxygen. Okay, boron, if you take a look at it, it's box number 1, 2, it's number 3 on the periodic table in its row. So boron is going to have 1, 2, 3 valence electrons. Oxygen is number 4, 5, and 6 on its row. So it'll have 1, 2, 3, 4, 5, 6. And again, boron wants to lose 3. Oxygen wants to gain 2. And so since we know that boron wants to lose and oxygen wants to gain, we know that the electrons are going to go from boron to oxygen. So let's start moving the electrons. So it looks like oxygen wants to gain 2. So what we're going to do is we're going to move 2 of the electrons from boron to oxygen. And now this oxygen is happy. It's happy because it gained the 2 electrons that it wanted. So I'll draw a smiley face. Okay, oxygen is happy because it gained 2 electrons. But if you look at boron, boron is unhappy, right? Boron is unhappy because it still has 1 electron that it wants to get rid of. It wants to lose 3. And so what we have to do now is we need to add another oxygen. We need to add another oxygen that can take the electrons from boron. So what's going to happen is boron is going to give 1 electron to oxygen. And so if boron gives 1 of the electrons to oxygen, now this boron is happy. This boron is happy and good to go because it got rid of all 3 of its electrons, valence electrons. Okay, but what's the problem? This oxygen is unhappy now because it gained 1, but how many does it want? It wants to gain 2. And so what we're going to have to do again is we're going to have to add another boron. We have to add another boron, which has 3 valence electrons. And what's going to happen is that boron is going to give one of its valence electrons to oxygen. Now this oxygen received two. It received one of its valence electrons from the first boron and one from the second boron. And so now this oxygen is happy. Okay, but you guys kind of see a pattern. This boron is unhappy because it got rid of one, but it wants to get rid of three. So it still needs to get rid of two valence electrons. So what we're going to have to do is we're going to have to add one more oxygen. And again, this oxygen wants to gain two. This boron wants to lose two, or it has two it wants to get rid of. So it's going to give both of the valence electrons to boron. And now, since this boron got rid of all three of its valence electrons, this boron is happy. And this oxygen gained two exactly, so it's going to be happy. Now, everybody is happy. And now all of these can come together and make one molecule. Okay? So if you guys ever find yourself in a situation like that where you can't balance out the elements, don't worry about it. Just keep adding the positives and the negatives until they balance each other out. So this is going to be right here what your picture should look like. You don't need to draw the smiley faces, but you have to draw the arrows. Okay, and then for the last part, let's write the chemical reaction. Okay, so we're going to start off with our starting materials. So it looks like we have two different boron atoms, so we'll write 2B. They're going to react with 1, 2, 3 oxygens, so 3 oxygens. And again, they're not combined, they're separate, so we have to write it like this. Do not write it like that, because that means they're stuck together. And then they're going to combine, and they're going to form, how many B's are there going to be? There's going to be B2 and O3. So what that means is, on this side, we had two separate borons. We combine that with 3 separate oxygens, and then they're going to form B2O3. All of them are going to combine together to form one molecule. Okay, so hopefully that was helpful in helping you understand ionic compounds and how they form. Just remember that the metals are going to give the nonmetals their electrons, and then that's going to allow them to come together to form an ionic compound. Okay, let me know if you guys have any questions, and we'll see you guys next time.